So topic 27 is about solving logarithms. Exciting. Yesterday we looked at, rearranging, expanding, simplifying. Today we're going to look at solving them. And it's actually not that challenging. Okay, let me explain. One, you need to know how to solve algebraic equations to do this. So as long as you know how to solve an algebraic equation, there's only a couple of differences between solving a logarithm and solving something, from back in chapter or topic 5 or whatever. I don't even know what topic it was, when we solved like 3x equals 1. It's very similar to that, but we do need to apply the rules of logarithms. So I'll very quickly read the guidelines, the rules, and then we'll look at a million examples because there's a lot of different examples for this type of equation. Okay, sorry about that. Isolate the logarithms on one side of the equation. So step number 1, put any logarithms you have on one side of the equation. You'll see this is typical guidelines. You'll see some exceptions to this, which I'll show you in a minute. Write a sum or difference of logarithms as a single logarithm. So this is what we were doing yesterday. What this means is combine them, simplify them, make them smaller. So all of the stuff we did yesterday about shrinking logarithms, this is kind of what we're going to use for today. Rewrite the equation in step 2 in exponential form. Solve the resulting equation from the previous step, and then check your solutions. Now, these are just guidelines. These aren't what you're going to do in every type of situation. So let's look at examples with logarithms on both sides of the equation. So you can see 2 examples of logarithms here. Log 5x minus log 5(3) equals log 5(7). Well, this surprisingly is a very easy one to solve. What you do first is, and like you'd almost be tempted to say, oh, okay, well, x minus 3, like let's get rid of the logs. X minus 3 equals 7, easy. But that's not how you solve logarithms. We're going to apply our logarithm rules. Subtraction means division. So log x minus log 3 becomes log x over log 3. Now we can remove the logarithms and just solve x over 3 equals 7. Very easy. X equals 7 times 3, or 21. Yes.
Mr. The log, when is it the same in the 2 different and 2 equal? It's remove it?
Yes. In this, yes, yeah. Yeah. So if you look at question B, same thing. I have 2 log 4 plus log x equals log of 1 minus 2x. So what I'm going to do first is expand not expand it, but simplify the logarithms if I can. So on the left, I can move the 2 over, so it becomes 4 squared, and then it's 4 squared plus x, so that becomes multiplied. This step you don't like, sorry, I'm not crossing it out because it's not important, but all this step is doing is squaring the 4 to give you 16, and then you take the 16 and you multiply it by x. That's equal to log 1 minus 2x. So you can get rid of the logs on both sides and solve this equation. Pretty easy. So 16x equals 1 minus 2x. I won't go over how to solve that. We've been solving this stuff for months. So why don't you guys practice a couple? There's only a few. Sorry, I'm just thinking. why don't you guys try B and C? Try these two. So I'll give you a minute or so to try these, and then we'll look at the answer. All right, so I'm getting a couple answers in the chat there. Looks good. Just take one more minute and we will look at the answers. All right, let's have a look at these answers here. I'm not getting a lot of answers because, and this is interesting because you guys can put these into the chat. You know, you don't have to type anything. You could just say the answer is like 3 or 4 or 5. So hopefully you guys are getting this or at least trying this. But let's look at the answers. Okay, so first things first, we're going to combine our terms here. So log 5x equals log 524 over 3. Sorry, that doesn't look like a 3. There we go. It still doesn't look like a 3. So that would be log 5x equals log 5, 8. Then you can get rid of the logarithms. X equals 8. Done. Easy. All right, what about C? log 7x plus 4 plus log 7 2 equals log 720. Now, again, I really encourage you, you can't just get rid of the logarithms. This is why we spent all that time yesterday combining them. The first thing I'm going to do is combine these. So I would get log 7. Now, this would be 2 times x plus 4, 2 times this because they're added, equals log 720. So, I mean, that's it, really. I can get rid of the logs. So I have 2x plus 4 equals 20, x plus 4 equals 10, x equals 6. Easy. I'm going a little quick through the algebra part there because, we've been doing algebra for a very, very, very long time. Okay, so these are considered easy ones. Let's look at some harder ones. Let's consider with logarithms on only one side of the equation. Okay, so this is a little harder because we only have a logarithm on one side. So we can't cancel logarithms here. So in examples like this one on page 69, we must use the rule 3 or not. It's not, these aren't rules, sorry, these are not rules. We will use guideline 3. We're going to need to rewrite the equations in exponential form, so you'll see me do that here. So log 2 x plus 2 plus log 5 equals 4. Okay, so step number 1, very easy. Combine your combine your logarithms to be one term. So 5 times x plus 2. Now, the question you guys might be having is, how did we get from this step to this step? Well, the properties of logarithms, we did this before your test. So before you guys wrote the test, you studied this. You can change a logarithm. Oh, sorry, I'm writing up in the top right of the screen. You can change a logarithm to exponential form using the following formula. So what I'm going to do is, there's no log to cancel from both sides. So what I'm going to do is I'm going to say, okay, well, this becomes log b times y equals x. So b, y, x. I don't know if I can write that. B, y, x. There we go. I kind of got it in there. So when I rewrite that, it becomes y equals, so 5x plus 2 equals b to the power of x. So 2 to the power of x. You'll see, well, we'll do some more of these as well. Now I just solve this. So 5x plus 10 equals 16. 2 to the power of 4 is 16. And then you solve. Again, I'm not really going to go through the solving because you guys should be pretty good at solving algebraic expressions. Okay, so let's look at this one. B. So x plus 3 divided by x minus 3. So that's there. Now what I'm going to do is, oops, sorry, I shouldn't have scrolled down. So once I have log 4 and I have my term here, what I'm going to do is turn it into exponential form. So this is my b, this is my y, and this is my x. So y equals b to the power of x. Again, all I'm doing is I'm changing it from a logarithm into exponential form. So I get x plus 3, x minus 3 equals 4 to the power of 2. And then I solve. Again, I won't go through the algebra here, but I solve this equation. So the answer to this is 17/5. So there's a bit, oh, there's only two examples to practice here. Um, well, I'll give you a minute or two. Why don't you guys try these two problems and then we'll look at the answers. So try these. Oh, and I will write this down for you on the bottom. X equals log by, y equals bx. So you can use what I have written on the bottom to help you solve these. So I'll be back in a few minutes. Let me know what x equals. You know, is x 3? Is x 4? Let me know in the chat. Okay, let's look at the answers here. Well, I'll leave the, no, maybe I'll erase the word try. Whoa, sorry about that. You guys, I don't know if you even saw anything happen just then, but my screen went crazy. All right, so let's look at the answers to this. So again, we will apply the rule of logarithms. Okay, equals 1. What I mean is we'll apply one of the many rules of logarithms. So we'll combine the 5 with the 2x plus 1. And then we will rewrite this in exponential form. So this is going to be 5 times 2x minus 1 equals 2 to the power of 1. So this becomes 2x minus 1 equals 2 over 5. 2 equals 2 over 5 plus 1. Sorry, 2x equals 2 over 5 plus 1. So let's see what this is. I'm just going to use my calculator for this. So that's 7 over 5. And then finally, we can solve for x. X will be 7 over 10. All right, question B. Put these together. So this would be log Now, oh, this is actually an important thing here. This one, B, I should have mentioned this before you even started. When you just see log, that's actually base 10. We talked about that in the class before the test, so it's been a while since we've talked about that. But when you just see the word log, it's not a 1. There's a 10 there. The logarithm button on your calculator represents log base 10. So this is going to be log 10 x plus 1 over x minus 1 equals 1. Then I put it in exponential form. So x plus 1 over x minus 1 will be 10 to the power of 1, which is just 10. So finally, well, not finally, but then what I'm going to do is I'm going to move the x minus 1 to the other side. Okay, so x plus 1 equals 10x minus 10. And then I'm going to keep solving for x. So I'll end up getting 9x equals 11. X equals 11 over 9. There you go.
Mr.
Yes?
Mr. Rene, why I didn't multiply 5 times 2x and 5 minus 1? It will be 5,
We
5x minus 5.
Yeah, we didn't need to because instead of multiplying it, I just moved it to the other side of the equation.
I have my final answer was 7 over 5 because I multiplied it.
No, we should get the same answer. Yeah, so I think you made a mistake in there.
Yes, I when I make it like 5 multiplied 2x, it was 10, but
Yep.
Same answer, 7 over 10.
7 over 10, exactly. Yeah.
Yeah.
Yeah, it doesn't matter which way you do this. You can multiply this in if you want to, but the answer will be either way, and that's why math is so beautiful. Everybody should get 7 over 10. Thank you for that, guys. All right. Wow. What about another example? So third, is there another one after this? I think this is it. Yeah, and then there's like a bunch of practice. Topic 27, I think, is pretty short, actually. So we will do, oh no, then there's this one. Yeah, okay. Sorry. So where's topic 8? Why is topic 7 so big? Wow, topic 7. Anyways, okay, sorry. Topic 7, we'll only do topic 7 today because it's huge, apparently. I don't know why it's so big. All right, so let's look at another example. I mean, these are all pretty much the same. We're applying similar rules. Well, I mean, yeah, this is very much the same example. So it says, let's consider examples where we must rearrange the equation. These examples show the importance of checking your answers as well. So solve this equation. Well, what we need to do to solve this equation is we need to get the logarithms on one side. These are all in your guidelines as well. So earlier when I was reading your guidelines, these were part of your guidelines. So it says isolate the logarithms on one side of the equation. So step number 1, I would move this logarithm over to the left side. All right, now all I do is do exactly what I did before. I solve it just like I did before. Here's the problem with this, sorry, not the problem, but here's why this question is challenging. Is when I solve it like I did before, so, you know, I rearrange the logarithm here to get this quadratic. Sorry, I then need to solve the quadratic. Now, when you guys solve a quadratic equation, I don't care what method you use. You can use the quadratic formula, you can use factoring, you can use completing the square. All of this was done on your test. The book is using here the zero product rule, which again, we did all of this in class. But when we solve the quadratic, we get 2 solutions. And when you get two solutions, you need to make sure you check your answers. What I mean is -1 is not going to work in your logarithm. If you try -1 in this logarithm, it's not going to work. The 4 will work, but the negative is not going to work. So when the book checks 4, the 4 checks, they just put the number 4 in and it's true, no problem. But the -1 will not be true. So if you are solving a logarithm, make sure you check your answers. Like again, if you checked x equals -1, if you did log base 4 of -1, it on your calculator says error. It's not going to work. This does work. So, I mean, again, there's not much new to teach here.
So, sir,
Yes?
what's the difference between this question and the question before?
The difference between this question and the question before is, one, we had to rearrange the equation to get the logarithms on one side. And two, we had a quadratic that we needed to solve. But everything else is identical. It's the same.
Oh, okay. Thank you.
No problem. All right. Well, let's look at another one. Okay. So this one's a little interesting because it's a natural logarithm. All right, sorry, I'm just thinking of how I'm going to explain this. So we did this before your test, actually. So it's been a while since we looked at this. The thing about a natural logarithm is it's the same as a log, but what a natural logarithm secretly looks like is, well, I can write it like this. So x equals, let's say, the natural logarithm y. When I turn that into an exponent, that would become y equals e to the x. Now, where did that e come from? Well, a natural logarithm is always to the base e, always. We just don't write it there because the base of a natural logarithm is always e. With logs, you can have log base 3, you can have log base 10, you can have log base, 67. It doesn't matter. For a natural logarithm, it's always log base e, and it's not written there because it's always there. It's very similar to like this. If you look at the buttons on your calculator, the calculator button, well, actually, this is actually, I just noticed something looking at my own calculator. Hold on. I'll show you something. Maybe it'll make sense. Maybe it won't. Oh, no, that's not what I wanted to do. Oh, here it is. I already had it open from yesterday. Perfect. Okay. So this question, or the buttons on your calculator, let me get my pen here. The log button stands for base 10. The ln button stands for base e. So the shift of your logarithm, like when you press shift of the button, it's actually showing you how to change it into exponential form. So, we know that x equals log by and y equals b to the x. Well, just look at your calculator. Second function of logarithm is 10 to the x. So x equals log 10 y. Y equals 10 to the x. That's what the calculator is saying. Same thing. So for a natural logarithm, x equals ln y. Y will equal e to the power of x. And again, that's what your calculator is saying. So if you forget this on a test or something, you can use your calculators to help you. I'm a big fan of, calculators and letting them help us. All right, so back to the notes. This again is nothing new. The difference is we're using ln instead of log, but everything else stays the same. So first things first, I combine my terms. So I put all of these logarithms on one side. Isolate the logarithms on one side. Okay, so I put all of the lns on one side. Then I'm going to write this as a single logarithm. So I would have x plus 2 times x minus 1 divided by 9x minus 17. Then I put it in exponential form. So again, did I have that written up top? Yep. So ln e equals 0. So that means this part is my y, e to the power of 0, and I solve my equation. Why is it e? If you're wondering why is it e to the power of 0, it's because I take this e and raise it to this power. So 1 equals this. Then I solve this one, and this one's a very challenging one because this is kind of like what you were doing on your test this week. You have to solve this by simplifying it. So, I multiply both sides by the LCD, which is what I'm doing here. You guys remember that from yesterday or from Tuesday? I multiply by the LCD. That gets rid of the fraction. Then I solve for x. And again, I'm not really going to go through solving for x. We'll do some exam review at the end if you have questions about factoring. So they factored this, and we get two solutions. X equals 5, x equals 3. Now, we want to check both. I can guarantee you that if they're both positive numbers, they will both work. They only don't work if they're negative. So if you check both of these numbers in your calculator, they are both true. Okay, so I think that's sorry, it's not it. Like there's a couple more things I want to talk about today. But guys, there's a billion practice problems here, like an obscene amount of practice problems. So why don't you guys try a couple? Like, yeah, let's go in the middle here. How about you guys try these? I will put myself on mute. I'll give you guys a couple minutes to try these, and then we will look at the answers. All right. So take a few minutes, try these, then we'll look at the answer. Okay, another minute or so, and we'll look at the answers. Again, you can put them in the chat. No problem. Okay, so let's look at some answers for this one. All right, so Q is quite easy, but then R, S, and T get a little bit more challenging. So that's kind of why I picked these examples. Again, Q a little challenging, but R, S, and T, sorry, Q a little easy, R, S, and T a little challenging. So for this one, there's a few ways you could look at this one, but realistically, all you have to do is, sorry. Oh, hold on 1 second, guys. Just 1 second. My phone is ringing. 1 second. Okay, sorry about that. So, all right, first, this one's kind of easy. This is kind of like one of the first examples that we did. All you have to do for this one is you could move the two logarithms on the same side and solve them that way. So one thing we could do is move the logarithm over. So log x plus 2 minus log 3x minus 6 equals 0. And then we can divide. So remember that log is base 10. So x plus 2 over 3x minus 6 equals 0. So now I'm going to put this in exponential, or sorry, exponential form. So x plus 2 over 3x minus 6 is equal to b, so 10 to the power of 0, which is 1. Okay, sorry, 10 to the power of 0 equals 1. If you don't believe me on that, you can try this on your calculator. 10 to the power of 0 equals 1. So this interesting part about this equation is what we end up getting is x plus 2 over 3x minus 6 equals 1. Now I'm just going to solve this. Now, guys, I'm going to have to write all over this screen here just to fit it in. The interesting part about this is this shows us there's an easy way to solve Q. And I'll explain that in a second, because what I'm going to do now is multiply both sides by the LCD. The LCD is 3x minus 6. So I get x plus 2 equals 1 times 3x minus 6. I think I might have just said the LCD is 3x plus 6. It's 3x minus 6. So I multiply both sides by my LCD. Right? And then I end up with this equation. Now, what we did earlier, and this doesn't work for every equation, by the way. Like what I'm about to show you does not work for many of the equations. Like it won't work for R and it won't work for S. But with Q, we could have just dropped the logs from both sides and started with this. But the reason I showed you all that is because no matter which method you do, you'll never be wrong. The problem I have with the method where we cancel the logs is it will not work for R. So you can't always use that. I don't want you to rely on that, but it is a shortcut here. So now I'll solve for x. I'll end up getting 2x equals 8. X equals 4. All right, so we could have, again, like I said, used a shortcut where we cancel the logs or we remove the logs. That will not work for every question. So be very, very careful with that method. Now, guys, I'm going to have to erase my writing. So just take a minute. You can write it down. You can take a screenshot, whatever. But I am going to have to erase that in just a minute. What I can do is start talking about R. Sorry. So for question R, I can combine my like term. I keep wanting to say combine my like terms. What I mean is I can combine these two things and then set it equal to 2 and put it in exponential form. Whoops. There we go. Didn't mean to do that. Oh, that's a good thing to know if I change the color. Okay, so log 3 of k times 2k plus 3 equals 2. I don't know why I used all those brackets, but it doesn't really matter. Okay, now I put it in exponential form. So k times 2k plus 3 is going to equal 3 to the power of 2, which is easy. That's just a 9. So now I just solve this like we would have in chapter or topic, whatever, what you guys did on your test the other day. So I would get 2k squared plus 3k equals 9. 2k squared plus 3k minus 9 equals 0. And that's it. Now we solve for k. So you can factor this any way you like. You can use the quadratic equation. You can use set it up like a product. So two numbers that multiply to equal 18 and two numbers that add to give you 3. Or 3. You could do it any way you want. So I'll kind of leave this factoring up to you guys. I know some of you, just from looking at your test, you like the quadratic formula. That's fine, but that takes a very, very long time to do. So anyways, this guy factored is going to be 2k minus 3 times k plus 3 equals 0. And now I'm going to solve for each k. So 2k minus 3 equals 0. 2k equals 3. K equals 3 over 2. That's my first answer. My second answer is k plus 3 equals 0. K equals negative 3. Now I can check my answers, and when you check your answers, the negative shouldn't work. You can try it in on your calculator if you want. So like log base 3 of negative 3, error. The negative will not work. K equals 3 over 2 is my solution. All right, so let's look at S. Ln x minus ln 4. Remember, if you weren't in class yesterday, when I say ln, I mean ln. So ln x equals ln 4x minus 9. Okay, so that means I'm going to combine them. ln equals x over 4x minus 9 equals 0. Now I'm going to change this into exponential form. So I get x over 4x minus 9 equals e to the 1. And then I'm going to solve that from there. All right, hold on one second, guys. All right, sorry about that. I'm doing some stuff at work, and there's people calling me from work, so I'm just trying to tell them to call me back later. Anyways, okay. So now we solve this. So e to and I did the same thing. My brain is going faster than my hands. It's e to the power of 0. The reason I wrote 1 there is because e to the power of 0 is 1. And sorry, my brain just kind of skips a step. So when I write it down, anyways, it doesn't matter, but it's e to the power of 0. I'm just using this property. So x equals ln y. When you change that to an exponent, you would get y equals e to the x. Okay. So this becomes x 4x minus 9 equals 1. And then, of course, I'm going to solve this. So multiply by the LCD, which is 4x minus 9. That means x will equal 1 times 4x minus 9. So I'll just get rid of the 1. We don't need the 1. And this one's nice and easy to solve. So in this one, we would get what? We would get 3x equals 9, x equals 3. Perfect. All right, one more, because I said for you guys to try T as well. And then there's two little things. We're still in the same topic. This is a huge topic. But anyways, there's two other things I want to show you, and that'll probably be it for today. All right, so question T. All right, the reason I'm kind of stalling here is because I know some people write this down, but I need to get rid of my writing to actually do T. Actually, T could be done pretty quickly. All right, I got to get rid of my writing. I'm sorry. Boom. All right. So log 5, 3t plus 2 minus log 5t equals log 5, 4. Okay, first things, let's combine these logarithms on the left. So log 3t plus 2 over t equals log 5 to the 4. Now I have logarithms on both sides, so I can get rid of them and just solve it like this. 3t plus 2 over t equals 4, and solve it like normal. So what we'll get is we're going to multiply both sides by t to get rid of it. So it'll end up being 3t plus 2 equals 4t, and then we'll solve for t. So t will end up equaling 2. That's it. Not too bad, right? The real challenging one here was at R. And again, if you're wondering why, let me zoom out so you can see my writing. But if you're wondering why in R, why couldn't we cancel the logarithms? Well, when you simplified R, sorry, I'm zoomed out so it's hard to write. There wasn't a logarithm on both sides. This was a logarithm, this wasn't. So we couldn't cancel the logarithms on both sides. So just to answer that question, if anybody had it, you know, how do you know or when can you cancel the logarithms? As long as the logarithms are for every number, you can cancel them. But if there's a single number there without a logarithm, you can't do it. So like in V, for example, in V, you cannot cancel the logarithm. Whoa, sorry, somebody's yelling at me.
Yes, Mister. Can I take? I put the log in the left side and equal 0.
Yes, you could. That works as well. Absolutely.
Okay.
Yeah. All right, guys, there's a million practice problems here. I highly recommend you practice this. So much practice here. Definitely practice this. You will see a question like this on your final. So practice. The reason this is so good to practice, by the way, is because you can practice factoring as well. So you can kind of, by doing these questions, you can practice a few things: logarithms, factoring. It's definitely worth your while to practice these, and you can check your answers. They're at the end of the topic. Okay. I think there's 2 more little things, and that'll be pretty much it for today. Again, my goal here is to finish topic 27. So, okay, we looked at solving exponential equations. We looked at solving logarithmic equations. What if we want to solve exponential equations? What do we do there? Well, the thing about solving exponential equations is it can be quite easy if the bases are the same. If the bases are not the same, we can actually use logarithms to help us. So this is kind of one of the reasons why you're learning about logarithms. If you had to solve something like y, I don't know, 1/12 to the power of x equals 3/2. How would you solve for this x, right? Very tough. And one of the reasons we're learning about logarithms is we can use the properties of logarithms to actually solve for exponential x's. Okay, let's start with the easy one first, though.
I can do it in the calculation.
No.
In the calculator.
No. Not in a Casio, you can't. You can't. Sorry. What I'm trying to say is, if you get a question like this, you can't enter that on a Casio calculator. Not that I know of. You have to solve it using algebra. Okay? Yeah, no, okay, all right. So,
okay.
Question number A, solve the exponential equations. Of course, I have to talk about the rule. Equivalence of exponential expressions. If you have an exponential expressions with the same base, then you can make the exponents equal. So what do I mean by that? I mean, if we had 2 to the power of x equals 2 to the power of 10, you can actually just get rid of the 2's. X equals 10. Okay, so we're going to look at that. These are very easy. Well, actually, no, I shouldn't say that. The challenge with these is to reduce them to exponential form to see if they have the same base. So 9, for example, we can reduce to be 3 squared. And there's no rule or no formula I can give you for this. You just have to try it. You have to practice it. Or, you can use, like the student just said, you can guess and check on your calculator. I'm trying to figure out, what can I rewrite 9 is? Or 9. Well, 9 is 3 squared. So 3 to the power of x equals 3 to the power of 2. X equals 2. 2 to the power of x equals 16. Well, I can write 16 as 2 to the power of 4. So x equals 4. I love C, 5 to the power of x equals 5 to the power of 7. Well, x is 7. Oh, this one's a tricky one, question D. So D, there's no way to get 4 and 8. Like looking at this, I don't know what to do. I can't get 4 or 8 to be the same base. But I can rewrite 4 as 2 squared, and I can rewrite 8 as 2 to the power of 3. So what I end up getting is 2 squared times x equals 2 to the power of 3, and then I just solve. Right? Well, that's not the answer, but I just solve the exponents. 2x equals 3. So when the base, and guys, I have a good news about this. If this confuses you, if you're like, what? Like, I would never be able to figure out that 16 is 2 to the power of 4. There's another way around this where you can do something else. And that's personally my favorite part. So I am going to ask you to try a couple of these. But personally, oh man, this is how I would always do it. Okay, so I'll give you some time to practice this. It'll take a few minutes, but if you're still confused after that, I have another way to do it, and it always works. So, anyways, let me let you guys practice. So, why don't you just take a minute and try these? You can just try like A and B. You could try C if you want, and then we'll look at the answers. All right, so take a minute. We will look at the answers. All right. Nice. I'm actually getting some answers in the chat there. That's excellent. So let's see what we get. Okay. So question A, 9 to the x equals 27. Well, not much I can do here unless I get the same base. So I can rewrite 9 as 3 squared times x, or, to the power of x. And 27, I think, is 3 to the power of 3. Again, you can check all this on your calculator to make sure. Okay, so 2x equals 3. X is 3 over 2. No problem there. Question B. Okay, there's not much I can do with B on the left. Like, I know it's going to be 3x equals something. Like, I can't mess with the B, or sorry, with the left side of B. So what I need to do is figure out how I can, put 81 to the power, or raise 3 to the power of something to be 81. So you can try some numbers here. Like I'm going to try 4, and sure enough, that's what it is. So 3 to the power of 4 is 81. X equals 4. Done. Easy. Okay, this one. Well, all right. I have 4 and I have 32. Now, 32, there's not, like, you can check this if you want. 4, you can try 4 squared, you can try 4 cubed. You're never going to get it to work. 4 squared is 16, 4 cubed is 64. So 4 is not going to work. So what that means is I'm going to have to change the 4 to be 2 to the power of 2 to the power of 3x equals 2 to the power of what? So 2 to the power of what is 32? I think it's 5. Yep, 2 to the power of 5 is 32. And then I still have a 3 there. Okay, so this becomes 6x equals 15. X equals 15 over 6. All right, I'm just checking because in the chat, Fatima's got something different than me. And that could mean that I'm wrong or one of us is wrong. So, and it could be me. I'm just double checking.
Mr. I have the 4 is power 2.5.
No, no decimals. No decimals.
Same. We can divide it in 3 and it will become 5 over 2.
7.5. 4 power 7.5. And is it the same? 5 over 2, the x. I have like that.
Sorry, what do you mean?
My x equal 5 over 2.
I don't think it's 5 over 2. But well, it might be because Fatima got the same thing. What am I messing up here? I'm not seeing what I'm messing up.
It's the same. We divide it in 3. So it's become 5 over 2.
Oh, yeah. Sorry. Yes. Yeah. You guys are just reducing it. Yeah. So this is good, but it's not the reduced fraction. Yeah. Sorry about that. My brain wasn't thinking. So for anybody watching or listening, they're just reducing the fraction. Yeah. Which is what you're supposed to do. Yes. So 5 over 2. Perfect. All right. Cool. That was funny. Been a long week. Okay. So there's more examples still, so I'll show you a few of these, and then there's only one more thing, and we're finally done. Topic 27. What a long topic this one is. So these are a little bit more involved, but still, well, not really. I mean, this is the same thing. It's just the algebra is getting to be a little bit more difficult. So let's look at number A. Okay, or letter A. 4 to the power of 2x minus 9 equals 64. Nothing I can do right there, but what I can do is try to find the same base. So I realize that 64 is, like, what I'm going to do is I'm going to use 4 as a starting point. Is there a number that I can get 4 to the power of to equal 64? Right? That's kind of where I start when I look at this question. The base on the left is 4. I'm not going to change it to 2 yet, right? I'm going to think about it. And then, on the right, I start thinking about 64. Well, 4 times 4 is 16, so 4 squared is 16. Then I try 4 cubed on my calculator. And yeah, 4 cubed is 64. So I set these guys equal to each other, and then I solve for x. Just use algebra. Very easy. I shouldn't have to explain 2x minus 9 equals 3 to you. So I'll leave that there. It does ask you to check it, and it does work. The answer, you don't actually have to check something like this. There's no reason that this wouldn't work. With logarithms, you might have issues with negatives. You won't have issues with this. So you don't actually have to check this. Okay, what about B? B is much harder. Okay, Oh, B is actually a very challenging one because you kind of have to, um, well, it's like solving a puzzle. You have to see the solution. Like you'd think to yourself right now, there is no way I could get 2 to be the same base as 1 over 4. But actually, and I'll zoom in a little bit here, actually, you could rewrite this as 4 to the negative 1, right? That's the same as 4. And then I could rewrite that as 2 squared to the negative 1 or 2 to the negative 2. This is a tricky one, right? If we gave you something like this, we'd be evil. Not saying we wouldn't on an assignment or something, but this is definitely a tricky one. 2 to the minus 2 is equal to 1 over 4. Now they have the same base. So the interesting thing about the base here is I have x times x plus 3. I know that this is very blurry, but what the blue is x squared plus 3x minus 2. Now we have a quadratic again. So quadratic, we need to solve it by, again, my personal, like when I was a student, or when I taught high school actually for a while. So this was a huge topic that we did in high school. And um, so I've done thousands and thousands and thousands of these problems between teaching and being a student myself. My personal favorite way to solve these is by factoring first. And if I can't figure out it by factoring, I use the quadratic equation. I never use the other methods in my personal life, like completing the square or the square root, like never. I try to factor first. And if factoring doesn't work, I use the quadratic formula. So this factors very nicely into x plus 2 and x minus, or sorry, x plus 2 and x plus 1. So we set both of them equal to 0 and solve. I don't know if you guys can remember this, but you know, if your factors are x plus 2 and x plus 1, what we learned back in whatever, I don't even know what topic it is, but we can set both of them equal to 0 and we can solve. So we have 2 solutions here. All right, cool. And again, you don't need to check these. The only thing I would check is logarithms, because logarithms you can't have negatives in, but these are fine. I don't care if you guys check your answers or not, actually. So this is good. All right. So why don't you guys try a couple? Let's go to like, actually, no, these aren't that bad. None of these are really that crazy. F might give you a little problems, but yeah, why don't you guys try these, D, E, F, and G, and then there's one more thing after this. There's just the last part of topic. This is it. This is the end of topic 27. Topic 27 is huge, so we won't be too much longer. But I would like to give you guys a couple minutes to try these. So give them a go. You know, at least if you can do D. You know, D is pretty straightforward, but I would try some. E is a little challenging. D and G, I think, are the easiest ones. But anyways, I'll give you a few minutes to try that, and then we'll check your answers. And there's one finale topic after that. All right. I'm not getting any answers in the chat, or am I? Let me see here. No. Okay, so whoops. Hold on, guys. Just kind of almost knocked over my mic there. Okay, let's look at these. So D, 4 to the power of 2x minus 1 equals 64. Okay, so let's zoom in a little bit. What are we going to do with these? Well, again, like I'm showing you all this right now, but in a second, like in the last part of today's class, I'm going to show you how to do this where you don't even need to worry about finding the same base. Like the hardest part of, like, I don't know, I wish I could skip this, and I was almost tempted today to just be like, nah, I'm going to skip this part. I think the other instructors taught it, or they're going, you know, they're teaching it, but I would never do this for a question like E or F or anything. There's a way to solve these that's much easier, in my opinion, which I am showing you next. This topic here, this last one, this will solve all of your problems. If you're having trouble seeing what I'm seeing, or like what I mean is if you're having trouble getting the same base, I have a solution for you, and it will make you very happy, I think. I hope, inshallah, right? So, okay, let's write this down with the same base. So 4 2x minus 1 equals 64. Now, we already saw this. I know that 4 cubed is 64. So this one's pretty easy. This is why I said at the beginning, hopefully you guys could solve this one, or at least solve this one, because this one's pretty straightforward. This is one of the ones where I might not use the method on the next section, right? This is a pretty easy one. Well, you know, maybe not. But we would get 2x equals 4, x equals 2, done, happy face, perfect. Okay, what about E? Now see, E, you guys might not see this, and like I wouldn't see this. The only reason I know that I can make this the same base is because it's in this section in the book. If I got something like E on a test, personally, I wouldn't do what I'm about to show you. I would do the thing I'm going to show you in the next section. So again, if you are looking at E and you're like, what? I can help you. I have there's a way to do this without worrying about the same base. Anyways, I am going to show you how to do it with the base. We just need to think of a way to write 81 and 243 with the same base. So I'm going to try some numbers here. It's probably going to be 3. So 3 to the power of 4 is 81. Like, remember, guys, I typically, you know, I'm a sciencey guy more than a math guy. So like a math person could look at that and say, oh, 243, gee, that's easy. That's 3 to the 5. And 81, that's 3 to the 4. It takes me a minute, right? I got to practice this. Or not practice, sorry. Try this on my calculator. So now that I know I can represent both of these with a base 3, there's a couple of things I need to note. Well, first, 3 to the power of 4, and then I'm going to have 3x minus 4. I'll multiply that out in a minute. Now for this one, I'm going to write it as 3 to the negative 5 because it is a fraction. Okay, so 12x minus 16 equals negative 5. 12x is negative 5 plus 16, which would be a negative or positive 11. So x equals 11 over 12. Done. Okay. It's 3 o'clock. I'll go a little quicker now. So, or not, sorry, I shouldn't say I'll go quicker, but I'll get these ones done a little quickly because again, and I know I keep saying this over and over, I'm going to show you how to solve these, in my opinion, much easier than this. But so I'll go a little quicker through this. 2 over 3 negative x plus 4 equals, well, this one's interesting because, well, okay, 2 to the power of 3 is 8. and 3 to the power of 3 is 27. So what this is actually, or what a way that we can actually write this is 2 over 3 minus x plus 4 equals 2 over 3 to the power of 3. So negative x plus 4 is 3. That means x is going to be 1. All right, cool. G. So we have a square root there. We don't want a square root anywhere, right? We want to get rid of that for this question. So I'm going to rewrite this as 3 to the power of 1/2 equals 3 to the power of 3 for x plus 1. So that means I'm going to get 1 over 2 equals 4x plus 1, and then I'm going to solve this. So this would be 4x equals 1/2 minus 1, which is a minus 1/2. X equals negative 1 over 8. All right, cool. So if you didn't like that, and I don't blame you if you don't like that, I'll help, or I have a solution I think that will help you. Again, like for me, question D and G, I can kind of see the answers. For F and E, I didn't see them right away. And again, the only reason I knew to put them as a common base is because the book is telling me to do that in this section. So you can practice all of these, but guys, I'm going to tell you an easier way to do this. Like, look at some of these. Like, look at N and O. Look at how challenging they might be. Maybe they might not be that bad actually, but there's an easier way for me to do it. For some exponential equations, and I'm going to actually say for most exponential equations, you cannot find a common base for both sides. So there's an example here, 4x equals 25. You cannot take, there's no way that you can make a 4 and a 25 have the same base. It's impossible. But what you can do is you can use the power of logarithms to help you. So this is why logarithms are cool. So how do you do it? Well, bring all of the exponential expressions onto one side of the equation. So, bring your x's on one side of the equation. Take the logarithm of both sides of the equation. You could use the natural logarithm, but we typically, like, what I mean is you could use ln, but we typically use log. Use the power property to remove the exponent. You'll see what I mean in a minute, and then solve the resulting equation. Okay, guys, I'm going to leave this up on the screen for a second. I just had to check something, and I'll be right back. Okay, sorry about that. There's a lot of stuff going on here today. I should have went into work. All right, so solving these equations. The problem with this one, we're almost done, by the way, guys. So like 10 more minutes, you'll be out of here. Problem with this is there's no way to get 4 and 25 to be the same base. But this is why I told you 10 minutes ago that you never have to worry about finding the same base, because really for every question, including these questions up here, like the ones I just did up here, or sorry, I went up too far, including these questions. So all of these, right? Everything you have it here, you don't have, like, who cares? You don't have to find the same base, because what you can do is take the logarithm, log, of both sides. So why does that work? Well, what happens is when you take the logarithm, you can use the power property to bring the x down, removing it as a exponential and moving it down in front of the equation. Then you can just solve for x, simplify. So here we would divide both sides by log 4, and you get your answer. I mean, that it's as easy as that, basically. Now, of course, we will look at some harder questions, but that's what you do. So, well, let's look at a harder question. So what about something like this? Earlier.
Mister, when I put log and when I put len.
What?
When I put log, when I put len.
It actually does not matter. You can use any one you want.
Okay.
Yeah, the book, and I'm kind of mad. Well, I shouldn't say I'm mad at the book. The book is good, but when I used to teach this in high school, I never even brought up the natural logarithm. I would just use log always. But the book is trying to get you guys ready for future math courses, so it's saying you can use log or ln. You can use whatever one you want, whatever one you prefer. Okay, I prefer log, but the book here is using ln or ln. It doesn't matter. That was a good question. So, 10 minutes ago, I would look to see if I could get the bases to be the same, but there's no way I could do that with 2 and 7, right? The only multiples of 7 that it's just not going to work, because 7 is a prime number, I guess. So it's nothing I can do. So what I can do is take the logarithm of both sides. The book chooses to use natural logarithm. Again, doesn't matter, but I'll go forward with ln, because that's what the book is doing. And what that means is once it takes the natural logarithm, we can then use the properties of logarithms to move the x's down front. Okay, and then I need to solve the equation just like we did before. I'm just wondering, do we need to do that step? I guess we do. Yeah, so in the next step, what we're doing, we got the logarithm. We applied the logarithm. We move the exponent down in front. So what we're doing in the next step is now the book, and this looks confusing, but all the book is doing is distributing this out. Okay, so we get x ln 2, 3 ln 2 equals x times ln 7. All right, so now you put all of the x terms on one side and then the number on the other. So again, this x moves over. Like, it's just like solving algebra. The x's go on one side, the numbers go on the other, which is why we get this one. Okay, and what they're doing, again, this one looks a bit crazy. This is actually a tricky one. What we would do next is I would factor, everybody's favorite thing, factoring. So here they're factoring x out. So if you remove an x from both of these, you would end up with ln 2 minus ln 7, and then just divide both sides by that number. You'll see. And this, by the way, guys, you have to do in your calculator. It's the only way to do it. It says here on the bottom, actually, this kind of goes with what the student just said earlier. How do I know when to use log or ln? The tip here says you can use logarithms too. You can use logarithms for anything. So there's one more example, and then we'll do a couple practice problems. I'll show you some problems for practice. It's not as bad as it sounds. Oh, actually, yeah. So for this question, if you do ever see an E, you do want to use ln. Okay, so if you do see an E, you do want to use ln. Like whenever I see E, my brain says, oh, there must be a ln or an ln in here somewhere. So it says here, the exponential expression has a base of E, so it's convenient to take the natural logarithms of both sides. Again, you could use log here. You can totally use log, but if you see an E, it is convenient to use ln. So like no way I could solve this by finding the same base. So what I'm going to do is I'm going to take the natural logarithm of both sides, which this then allows me to move the 3.6 down front. Okay. Now, technically, all you need to do now is to solve for x. I'll give you a little hint here that ln e is equal to 1, but you could put that in on your calculator and keep going with that. So this becomes negative 3.6x equals ln 9.74. I divide both sides by 3.6, and you'll get your answer. I don't know. I hate doing these examples. So let me show you a couple. Maybe it'll make more sense if I do a few for you. So, well, let me do an easy one. Then I'll do like a middle one or two, and then maybe I'll get you guys to try a couple, and that's it. So, all right, let's try an easy one to get warmed up. All right, 3 to the power of x equals 8x to the power 8 to the power of x plus 2. Sorry, that was hard to say. All right, no way I can get a common base here, so I'm going to take the logarithm of both sides. I'm going to choose log just because that's what I normally use. Unless there's an e, I personally just use log. Okay, so, oops, I wrote the first one a little funny. All right, now that I've done that, this allows me to move the exponents down in front of the equation. So I get x log 3 equals x plus 2 log 8. Actually, B is a pretty tricky one to get started with. Well, no, sorry, it's not tricky. It's just it's more work than I thought it would be for question B. Usually questions A and B are so easy. So I got a problem here now. I need to solve for x, but I got x's in brackets. I got x on both sides. So what I'm going to do is I'm going to distribute the log out. So I will end up getting x log 3 equals x log 8 plus 2 log 8. All right, now I'm going to put my x's on one side of the equation and my numbers on the other. So x log 3 minus x log 8. Oh, sorry. That's not a lowercase. It's not base 3. It's x log 3 minus x log 8 equals 2 log 8. All right, almost done. I'm going to factor out my x. And I have one step left to do. Now I'm going to divide both sides by log 3 minus log 8. Boop, and they cancel, so x will equal. Now I put this in on my calculator. So I'm going to use brackets. I'm going to say 2 log 8 sorry, 2 times log 8. I think my calculator might have had a problem with that. Divided by brackets. I'm going to use brackets here. Make sure you use brackets. Log 3 minus log 5. And I get my answer. Negative 8.14. Whew, that was a tough one. That one was, I figured, oh, B would be a nice easy warm up, but actually, no, B was pretty tough. All right, guys, we're almost getting to 3:30. So let me just show you another one or another 2. And then maybe I won't get you guys to practice. Maybe like over the weekend, you guys could practice this. So let's look at another one. Oh, sorry, I guess I'll leave that up for a minute so you can see. Let's look at question, well, C would be actually pretty easy. Okay, so let's look at C. All right, so for C, I'm going to take, because there's an E, I'm going to take the natural logarithm. Anytime you see an E, use natural logarithm. So I'm going to say ln of e to the x will be ln 8.1254. I don't know why they're using so many letters. Okay, so I can move the x down front. So this becomes x ln e equals ln 8.1254. Ln e equals 1. So that's it, guys. I'm done. I just need to put this in on my calculator. I'm going to press ln of 8.1254, and I get my answer, 2.094. All right, cool. Let's do one more, and then halas. Because again, I feel bad because B was such a challenging one. They're really normally not that bad. Like look at E. Well, I want to solve for T, so I'm going to take the logarithm of both sides. Okay, now this one's a nice one. This one's normal. I'm going to move the T down front, so I get T log 10 equals log of 0.0138. T, I'm going to divide both sides by log 10. There, that's kind of how they should be, right? That's a nice, easy, normal one. 0.0138. Sorry?
Can I see question B?
Yes. Sorry, I just want to write the answer for this. Negative 1.86. All right, so that's E. E is, E would probably be the one I should have started with because E is so simple. Take the log of both sides, bring the T down front, then divide both sides by log 10, and that's it. You get a nice normal answer. All right, guys, I'm done for today. This student wanted to see question B, so there it is. But if you guys want to go, you're free to go.
Minus 8.
Sorry? Not minus 8. I have minus 4.24.
Minus 4.240.
Okay,
yes, because this log 3 minus log 8, not log, what is this log?
I said log 5, didn't I, right here?
No, not log 5.
I know, relax.
Log 8.
I know. It is log 8. It's just I wrote 5. I made a mistake. Sorry. So that should be log 8, not log 5. So let me put that into my calculator and see what I get here.
Minus 4.24.
Okay, so let's see. I believe you guys. I'm just double checking to make sure. Sometimes my fives, I write them so quick, or my 8s, they look the same. But yeah, if this is a log 8, then this would be 4.24. All right, guys. So that's it for me. I'm done. I hope you guys have a good weekend. If there's any questions, let me know. Other than that, we are finished.
Okay.